Chapter 1, Section 2, Random Samples. So in this chapter, or in this section, we're going to go over different ways that you can collect a random sample. So you can't just go out and just willy-nilly just grab some samples and be done with it. There's actually techniques that you'd have to follow. So the first technique is called a simple random sample. So a simple random sample is a sampling technique that gives every member of the population equal chance of being selected. The pro of this is it's ideal for statistical purposes and can be thought as a mini population because everyone is being accounted for. The con is that you need an accurate list of your said population. So how you get a simple random sample is that you would have to assign every single member of the population a number, and then you would have to randomly generate numbers, and then the first how many numbers come up are the people that would get selected. Now there's going to be three different ways to do this. The first would be a table on A9, which I'll show you guys in class. The second way would be to use Desmos, which I'll show you in class. And the last way is to use any sort of number generator that you can just set that you want between 1 and whatever, and then just generate numbers. So that's the first technique. And then an example would just be you have 100 faculty and staff working at Conval. You want to pick 6. So you assign all 100 numbers, and then you pick the first 6 numbers that come up. This is how to do it on a TI-84. That's how to do it on Inspire. And that's how we're going to do it with Desmos. The second technique is stratified sampling. Stratified sampling is which the population is divided into at least 2 distinct subgroups. Random samples of a certain size are then drawn from each subgroup. The pro is that it gives a better precision because it ensures better coverage of the population. The con is sometimes it's difficult to identify appropriate subgroups. More complex to organize and analyze results. And it's not truly a random sample because you're saying, well, what if we just talk about age groups? So 14-year-olds, 15-year-olds, 16, 17, 18-year-olds go into your group, then I'm going to randomly select from those groups. So you're getting rid of some of the randomness by then having some restrictions. Technique 3 is systematic sampling. That's when the members of the population are sequentially numbered. So from a starting point, every nth member is included. So the pro is that it's easy to get. The con, not everyone has an equal chance of being selected. So for example, if you wanted to select every 4th person that walks into the classroom, the people that are closest to the classroom have less likely chance of being selected because they're going to get there first, second, or third. Likewise, if you're furthest, it might also be biased against you. And then at the hospital in Peterborough, you could survey every 100th patient admitted and then ask the questions you want to ask. The fourth technique is a more precise stratified technique. It's called cluster sampling. So cluster sampling is you're dividing into pre-existing clusters. So the stratified was you got to pick what the groups were. Cluster sampling is a type of stratified sampling, and it is specifically on your geographic location. So you're picked everyone who's from the same cluster. So it's easy because their clusters are pre-existing. The con, it's less likely to represent the entire population. So Conval is a great example of this. There are 9 towns that make up Conval. And then if you were just to reach in there and take 2 towns out and then survey those towns, you're still getting a sample of Conval. But if you're talking about surveying everyone who you selected and you pick out Temple and Sharon, then that would not be as accurate as if you picked a bigger town. But then there are other issues. So if you were to pick Dublin and Peterborough, depending on the questions you ask, it may not be applicable. So there are certain issues that come up with cluster sampling because of the geographic regions. Technique 5, convenience sampling. This is the one that is just, it exists because it happens. And we are going to be doing a survey project, and this is the one technique that you cannot use. Convenience sampling is sampling which data is used from a population that's just readily available. The pro, it's easy, sometimes better than nothing. The con, it can be very biased. And so it would just be like walking into a classroom and just saying, yep, you guys are going to represent all of Conval. And then this last slide, I call the vocab word simulation, a numerical facsimile or representation of a real world phenomenon. So I put phenomenon in quotations because I didn't realize this. Phenomenon just means an event. So if it can happen, it's phenomenal. I thought that was kind of funny. But so some examples of simulations is really when you need some sort of computer software to really break down what's going on. So for some examples, results of a car collision with crash dummies. You're not going to wait on the corner of a street and just look for a car accident and see how the seatbelts worked and how the engine collapsed and things like that. You're going to do tests and you're going to use computers to let you know the impact. And then other things would be like if you wanted to know the wind speed over a wing of an airplane. You're not going to be out on the wing during takeoff. You're going to use a simulation. So that was just one more vocab word we can add to our electronic word wall, and then our 5 techniques.